Hello, welcome to another episode of Sound Talk Show. Today we're gonna code advanced code in Wolfram language. Okay, we're gonna finish it as fast as possible, maybe 40 minutes to an hour. This is my keyboard, Kinesis 360, Ultimate Hacking Keyboard, Glove 80 keyboard, fantastic. These are the keyboard I recommend. Okay, so let's begin. So advanced code, let's show the screen. Problem number 7. So we did number 1 to 6 and not the part 2. Some of them we haven't done the part 2 yet. But I'm thinking I'm just gonna do all the advanced code, the first part first, then let's do the part 2. Because part 1, the problems are open to everyone. You can see the problem. Advanced code 2023. Okay, and okay, so let's begin. If you are here, say hi. Okay, if you like my stuff, donate. Okay, so advanced code. Let's start Wolfram language. Begin. Okay, new panel. 1 plus 1. Please show me 1 plus 1 equals to 2. Okay. And we need to magnify. Okay, so that's good. Let's magnify the window. Okay, so Wolfram language advanced code 2023, number 7, day 7. Xa, can you share the link to your Discord server? I couldn't find on xali.info. Okay, go to xali.info. It's obvious. Or just search for, you can probably find it. Xali Google, Xali Discord. Okay. Yeah. Okay. So well, let me just paste the link. Okay. You see Xali code. And Xa blogs, so many blogs on Twitter, on Elon Musk X, and there it is, Xa Discord. Number 6, hello, okay. Advanced code, number day 7, okay. Let's begin. Now, answer the question, okay. I'm wondering, I'm going to do, there are like advanced code up to 17 or something. So I'm gonna finish them all, okay, but I'm gonna do them like 1 per week. So I don't want to like congest them all in 1 month. 1 per week, so that we continuously have some code exercise to do for the Sound Talk Show. So I'm wondering, so one of the day I want to do a the Melangian zoomer thing, like quiet, like there's a word like tickle your senses. You just quietly talking and make some noises. So do you guys like to see that? Not today. Today I'm gonna talk and explain things, but I'm guessing down the road we're gonna do one like that. No talking, just like code. Okay, advanced code, day 7. Your all expenses paid trip turns out to be one way, 5 minutes ride in an airship. Can you see it? Let's see. Oh, okay. So this window needs to be there. Okay. So your all expenses paid trip turned out to be one way, 5 minutes ride in an airship. At least it's cool airship. It drops you off at the edge of vast desert and descends back to island. Did you bring the parts? You turn around to see an elf completely covered in white clothing, wearing goggles and riding a large camel. Did you bring the parts? She asked again. Louder this time. You aren't sure what parts she's looking for. You are here to figure out why the sand stopped. The parts for the sand, yes. Come with me, I'll show you. She beckons you onto the camel. After riding a bit across the sands of Desert Island, you can see what looks like very large rocks covering half of the horizon. The elf explains that the rocks are all along the part of the desert island that is directly above Island, making it hard to even get there. Normally, they use big machines to move the rocks and filter the sand. But the machines have broken down because Desert Island recently stopped receiving the parts they need to fix the machines. You have already assumed it'll be your job to figure out why the parts stopped when she asked if you can help. You agree automatically. Because the journey will take a few days, she offers to teach you the game of camel cards. Here comes the payload. Camel cards is sort of similar to poker, except it's designed to be easier to play while riding a camel. In camel cards, you get a list of hands, and your goal is to order them based on the strength of each hand, okay? A hand consists of 5 cards, labeled one of AKQJT987654 or 2. Okay, someone is knocking the door. Hold on a second. I gotta be back. Okay, got some errand to do. So I'm back. So let's see. Where was I? So advent of code. So camel cards. Game of camel cards. So you got a list of hands. Your goal is to order them based on the strength of the hands. A hand consists of 5 cards, each one labeled one of them, one of these letters also. Let's write it down. Can you see? Yes, okay. Okay, something like that. Problem description, list of hand. So these are the alphabets. The relative strength of each card follows this order. Okay, so A is better than K, K is better than Q, okay? A, K, Q, J, okay? Ace, King, Queen, Jack, and T, okay? They got a T, where A is the highest of the 2, okay? So, yeah, so back to the problem. So every hand is exactly one type. Okay, so there's no suits of clubs and hearts and stuff. So let's copy the problem description. So show in browser. So every hand is exactly one type from strongest to weakest. They are 5 of a kind. Jesus. 5 of a kind. Okay, so there's more than one kind. 5 of a kind. Where all 5 cards have the same label. Okay, 4 of a kind, where all 4 cards have the same label, and 1 card has a different label. Okay. Full house, where 3 cards have the same label, and the remaining 2 cards share a different label. Okay. 3 of a kind, where 3 cards have the same label and the remaining 2 cards are each different from any other cards in the hand. Okay, TTT98. 3 of a kind, full house. Okay, full house, 3 of a kind, 2 pair, where 2 cards share 1 label, 2 other cards share a second label, and the remaining cards has a third label. Okay, 2 pair. Okay, and 1 pair, where 2 cards share 1 label and the other 3 cards have a different label. Okay, that's 1 single pair. then a high card where all cards labels are distinct. Okay, so every hand is exactly one type from strongest to weakest they are. So every hand is exactly one of these. Okay, so each one of these is called a type, ordered from strongest to weakest. Okay. Okay, so this is kind of odd because it appears it doesn't cover all possibilities. For example, what about flush, right? Like 1, 2, 3, 4, 5. They don't have that. But anyway, so 5 of a kind, 4 of a kind, full house, 3 of a kind, 2 pairs, 1 pair, and nothing. Okay, hands are primarily ordered based on type. For example, every full house is stronger than 3 of a kind. Yes, of course. If 2 hands have the same type, a second ordering rule takes effect. Start by comparing the first card in each hand. Start by comparing the first card in each hand. If these cards are different, the hands with the stronger first card is considered stronger. Okay, so a second order, okay, start by comparing first card. There's something on my mind. Okay, so if these cards are, so start by comparing the first card in each hand. That's odd. If these cards are different, the hand with the stronger first card is considered stronger. Okay, if the first card in each hand have the same label, however, then move on to considering the second card in each hand. If they differ, the hand with the higher second card wins. Otherwise, continue with the third card in each hand, then the fourth. Okay, that's kind of odd. I mean, that's not conventional ranking, because they simply compare the first card as opposed to the rank of the, 4 of a kind. 4 of a kind, you might have A, S as the 4 of a kind, or you might have a king. So in that case, the king should be higher ranked, but that's not the case here. They simply order by the card number. I mean, by the first card and second card and so on, which makes the problem kind of easier, I suppose, because you just order them by kind of alphabetical. Is that right? T, okay, T stand for 10 actually. 10, 9, 8, 7, 6, 5, 4, 3, 2. Okay, so you got a list of oh God, I touched my. You got a list of hands. Your job is just order them. Okay, so 3332 and 2AAAA are both 4 of a kind, but 3332 is stronger because it's the first card, because the first card is stronger. Okay, idiotic. Similarly, 77888 and 77788 are both full house, but 77888 is stronger, right? Because the third number, 8, is greater than 7. Okay, that's so far so good. To play camel cards, you are given a list of hands and their corresponding bid. Oh God, it's more complex. So to play camel cards, you are given a list of hands, okay, list of hands, and their corresponding bid. So that's some kind of payload, your puzzle input, okay? Let's copy the puzzle input. So far so good? Am I doing good? Okay. So this is the input. And you have a weight attached to it for each hand, okay? so the corresponding bid, okay. This example shows 5 hands. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank. Multiplied by its rank, where the weakest hand gets rank 1, the second weakest hand gets rank 2. Okay, so you order them. So in this case, you got 1, 2, 3, 4, 5 hands. So you order them by rank and multiply by the rank. So basically, the multiplier is just ordinals, like 1, 2, 3, 4, 5. Okay, and so on. Okay, so multiply by the bid amount. Okay, and so on up to the strongest hand. Because there are 5 hands in this example, the strongest hand will have rank 5, and its bid will be multiplied by 5. Okay, so the first step is to put the hands in order. So that's the first job. Rank them by order of the hands. Okay, so let's see. So some kind of explanation to confirm that we understand the problem correctly. So KK677 and KTJJT are both 2 pair. Okay, their first cards both have the same label, but the second card of this is stronger, K versus T, yeah. So the first one is stronger. So wait, they are 2 of a kind, okay? I mean both 2 pair, okay? So KTJJT gets rank 2 and KK677 gets rank 3, okay? The higher the rank means they are more superior, right? Okay, so yeah, so if you want to maximize it, the bigger the bid, hopefully you have the better hand for the bigger bids. Okay, so now you can determine the total winning of this set of hands by adding up the result of multiplying each hand's bid with its rank. Okay, blah blah blah. So the total winning in this example are that. Okay, so now, so here is the puzzle solution. I mean so 6440 is a solution to this example input. Okay, you rank them, then you multiply by the rank. Okay, multiply the bid by the rank, and then you sum them up. Okay, so find the rank of every hand in your set. What are the total winnings? Okay, let's start to code this problem. It's already 24 minutes. Fuck. Okay, say hi. Okay, say hi. So, okay, let's see. Well, I'm not gonna check. So let's see the problem. So you get the text. So let's start coding Wolfram language. So you got input. Okay, so the input is something like that. Okay. Okay, so you first want to order them. Okay, you first of all you split the input by split by a new line. So well, let's do this. Okay, list of hands equals to that. Okay, so let's run it in Wolfram language. That's right. So they are strings so far. And okay, now the bits, you need to turn them to number eventually. So okay, so the first job is to rank them. So how do you rank them? Okay, so you rank them, basically you want to sort it. You want to sort it, so for example, let me show you. Okay, so for each line, let's not do this. So for each of the input, do we have refresh? Yeah, so we have the input here. So basically, you're just gonna order this list. Okay, trivial. So the key of the problem is finding the ordering function. Okay, and how do you gonna order them? Let's see. You want to, so okay, funky. So 5 of a kind. So this is basically, this is the English description of the ordering function. 5 of a kind. 5 of a kind. Okay, that's that's a bit odd because there's more than 4 kinds. Typically, in a normal cards you only have 4 kinds. So you got 5 of a kind, 4 of a kind. Then you got full house, which is better than 3 of a kind. Okay, so basically 3 of a kind, 4 of a kind, 5 of a kind, and you got a full house in between. Then you got pair. Okay, so the first job, we can organize the sorting problem, determine which one is by sort. So we can write a sorting function. Okay, so this is not a trivial problem. Trivial in the sense that you can code it right away. You have to think about. So a card, a hand is a sequence of 5 characters. Okay, 5 characters. You want to determine if they repeat, like 5 of a kind. Okay, so let's think about how do you approach. I mean there are so many ways. So 5 of a kind, 4 of a kind, 3 of a kind. Okay, so full house is also 3 of a kind, except that the other 2 numbers is a pair. It's the same. Okay, so one of the key is you determine how many, if this sequence of 5 characters, they have repetition. Okay, so then you have 2 pair, which is like 2 of a kind. Then 1 pair is 1 of a kind. Yeah. Wait. 2 pair is 2 of a kind. 1 pair is also 2 of a kind. They differ is that you have one of them is 2 of kinds. Okay. And the last one is all distinct. Okay. God. So you want to, sort them. You want to sort them. Oh God, this is not so easy. Okay, hold on a second. I'll be right back. Okay, I'm back. So now we are into this sort problem. We need to sort this thing. Not so easy. Sort. Okay, yeah, so you can sort them. You need a sorting function. Sorting function is that, so you classify a hand by this 1, 2, 3, 4, 5, 6, 7 categories. So you classify this sequence of 5 characters into one of these 7 categories. 1, 2, 3, 4, 5, 6, 7. Okay, 7 categories. And how do these 7 categories differ? They differ by, so the repetition of a card, okay, all of them the same. Then the second is 4 of them the same. These two are clear examples, no ambiguity. Then you have repetition of 3 characters. In that case, it's either full house or 3 of a kind. Okay, repetition of 3 characters. Okay, let's write it out. Given a hand, a sequence of 5 chars. They are one of the 7 types. Okay, so one of the type is all same chars. That's called 5 of a kind. Okay. Five same characters, 4 same characters. Okay, that's called 4 of a kind. Then 3 same characters. Okay, so in the case of 3 same characters, there are 2 cases. One is and a pair. Okay, this is called full house. Right? Is that how they call it in card games? Full house. Okay. Then no pair. So this is called 3 of a kind. Okay, then you have the case of 2 same characters. Okay, and this is called 2 pair. Then you have the case of 2 same characters but 1 pair. Okay, okay, so you can classify of them into, okay, then the last one is no char are the same. It's called high card. Okay, so you have these cases and in this particular ordering. So you determine, so there are 7 types of them. 7. Okay, there are 7 types. So each sequence of 5 characters belongs to one of these, right? And then, so, basically what you want to do is sort by. Okay, so sort by is a Wolfram language function that allows you to sort by a particular function. Okay, like that. Okay, so you want to sort by list of hands, and the second argument is a function. Okay, something like that. Okay, so this is basically what you want to do, and the key problem is to write this function. So this function, how are we gonna write this function? Right, you saw this list of hands. Right, so you saw this, so you got a list of ordered hands, right? So, but the key is writing this function. So this function will take x is one of these string. Okay, so first of all, we can say, for example, split string by space. Okay, then something. You split it. Okay, then you take the first part. Okay, so that gets you just the sequence of characters, the hand. Okay, then what you're gonna do with that? So in fact, we can just run this, so I can show you as we go. So we run this. Okay, select all, paste, run it. So you can see if we do it this way, so we got this order. This is simply alphanumerical order. You see, based on the first character, then the second character. So 3 comes first, K comes second, Q comes fourth, then T, right? Right, so we have to fix this ordering function. So we get so first of all, we get the first part, the card, then so let's do this. Okay, the module. Okay, hand string equals to that. Okay, then the expression. So what you're gonna do with that? So the hand. So okay, so then so what you're gonna do with it? So you got a sequence of 5 characters. So you want to determine if it repeats and how many times. First of all, let's see the sort by function. So the sort by function actually can take a sequence of functions. Fantastic. This is the power of Wolfram language, extremely useful. So the first function will simply compare how many repetitions. Yeah, let's do it the easy way. Let's forget about efficiency. Let's do it the most simplest way. This is the highlight of Wolfram language, because it allows you to prototype and get the answer as fast as possible. then you can worry about efficiency and what data structure to use and so on. So first of all, you need to know. So you see, sort by, you can have a bunch of functions. So the first, let's start to write some function. So one of the function is to determine if it's 5 same cards or not. Okay, so given a string, how many repetition of a char? That's, so you want to write that function. Okay, so this is a string. You want to determine how many repetition in the card. I mean in the sequence. So once you know the repetition, basically you almost solved it. So here is 0 same char. Okay, so once you know the number of repetition, you almost solved it. Then you need to, yeah, that's right. So the first job is to find the function that returns the repetition of a string. Okay, so that's easy. Let's query for any string function and repeat. Okay, repeated string, let's see what that is. Repeated string. Repeated string is an internal symbol used for formatting. Okay, that's not what we want. So we have to think about it. So given a string, we want to find what is the maximal repetition. Okay, now we, in Wolfram language, the best way to find the function is to ask the most logical question you want. To find a way to ask the most logical question. Once you got that, then the function name is almost exactly that. So what we want to know is that given a string, we want to find the maximum character repetition. Okay, so the words are occur, repeat, something like that. Okay, let's see. String take, string split, string replace, string part, string match, string extract, string contains, string cases, search query string. Okay, so how do you find the now in most other languages, the primitive way to do this is that you can use a hash table. So you go through the string character by character. For each character, you push it into a hash table with that character as a key. Then you go on to the next character. If that character is already in the hash table, in a dictionary, you just add 1 to the value. If not, then you create a new key, right? Once you're done, you have a dictionary of keys and values. The keys are the character in the string. The value is how many times they occur. Okay, so if you build this dictionary, if you can build this dictionary, then, oh yeah, that's the obvious way to do it in most languages. Once you build this dictionary, then the ranking becomes, it's all solved. The ranking is simply the maximum number, the maximum value in this dictionary. Okay, if that's a tie, for example, full house and 3 of a kind, then you find the second maximal value in this dictionary. So in the case of full house, the second highest value would be 2. So, and in a 3 of a kind, the second highest value is 1. So full house wins, right? So once you build this dictionary, the problem is solved. The ranking problem is solved. Oh, okay. So that tells us all we want is like in the Wolfram language, you just need a function that returns frequency. Frequency is the word. Let's see, FREQU. Okay. You know, there is a allowed frequency range, word frequency, character frequency. Let's see word frequency. Give the frequency of word in text. Okay, so there is something like a character frequency. Okay, so let's see occur. Let's see if there's any what? OCCU. Okay, there's no occur in Wolfram language. So there is char. Okay, so these are a bunch of function names containing the word character. Okay, so we want the character counts. That's what we want. That's right. Okay, fantastic. This gives us exactly what we want. It returns a dictionary. Okay. Character counts. Let's say a given example. Okay. Character count that. Fantastic. Exactly. So that's the function we want. So the character counts, yeah. So we want so once we have this dictionary, we want to you want to get a list of the. Okay, let's try it. Let's say equals to that. Okay, so x is a dictionary, and let's see what happens if you just sort it. Okay, if you just sort it, it sorts by the value, right? So if you simply sort it, it sorts by the value of the dictionary from minimal to maximal. Okay, so for example, let's do this. So for example, let's do sort at that. Okay, but now let's say 5555. Right. So then you just do max. Let's see what is max versus max value. What's the difference? Max value gives the maximum value of f with respect to x. Okay, maximum value applies a function, so that's not what you want. You just want max. Max returns the maximum, yeah, of a list. Okay, so you can see that's it. Okay, so we have a function. So now we, yeah, character counts returns a dictionary. Then you just return max. Okay, wait, character count, then sort. Okay, that's almost that's it. Let's just try what happens here. Okay, so now table form. Okay, so there it is. You see, the last one is the highest ranked. Exactly, that's how we want it. Because the last one, if we count by the index of the list, the last one would be 5. The multiplier for this one is 5. So you just 5 times 6, 8, 4. So here we have 3 of a kind, and here is also 3 of a kind. Now there's a trick. So they are equal. I mean, they are both 3 of a kind. And now to determine their ranking, you sort by the first character, right? Like the problem description. So Q comes before T. I mean, Q is queen, T is 10. So Q should be, right? Q should be at the bottom. But anyway, so here's 3 of a kind, 3 of a kind. Then here's 2 of a kind. This is 2 pairs. Okay, so let's see. Okay, so let's see. Let's try this. Okay, so let's try if we can do this. Sort a list 3, 4, 5. Now sort by default is what? Ascending or descending, sort code with 3 arguments. Okay, so you need so increase, it sorts from small to large. Okay, so now 3, 3. Now by default it should okay, so for example, this one 3, 2, 5, that's correct. It by default the sort will use the first element in the list. If that's equal, it will use the second element automatically. So back to our problem, we can, that's right, so we can just, yeah, so this actually works. So we don't want max, we want to sort. That's right. So what if we, now let's try the sort again, but this time have bunch of so we don't care what the key is. Okay, so we don't care what the key is. Let's just say k. Okay, we only care about the number. So okay, almost done. So sort increase. Okay, so they increase. Okay, can you reverse it? You can. right? You can just reverse it. So you want to do that. Okay, so you want to, okay, how you guys doing? Simple first is a good mentality. Hello, Aristocrats Coffee. Okay, very good. Very smooth so far. So now you character counts gives you a dictionary, then you sort it, but you want to reverse. Okay, so you don't want. Let's look up the documentation. There is an option to reverse them instead of calling reverse yourself, because then it's less optimal, I suppose. Okay, but where's the option? Oh, there is no option for sort. Funny. What? Am I correct? Wow, there's no option for sort. So the proper way is you simply revert it. What about this order? Gives, okay, so that gives order. What about sort by? Oh wait, there's reverse sort by. Interesting. So there's also reverse sort by. So we are using sort by. Eris. I'm surprised there's no sort. What do you mean there's no sort? There's sort. There is sort. Okay, we almost done. Just some of the details. So let me just concentrate, okay? So we got character counts, which is a dictionary. Okay, character counts is a dictionary. Okay, then you sort it. Now you don't want to increase order. You want them to be in decrease order. Okay, so instead of sort, you use reverse sort. It's interesting, it doesn't have an option for sort, but rather it just have a different function, reverse sort. Okay, so instead of sort, you say reverse sort. Okay, so you use reverse sort. So when you sort them, a dictionary, it basically just sort by the value. Okay, so we can try. Okay, so we can try this. Okay, so we need to what is this? So let's see, let's say 4, 3, 2, okay? So what happens if you, so 3, let's say 5, okay? Then let's say 4, and the second value, so this and this are the same. Now the second value, so this one, let's say 4, so this will come first, this will come first, then this, okay? Let's try it. Oh, we got a null here. What? Oh, we need to wait. What? Reverse sort. Reverse sort. Reverse sort input is the least, right? So input is the least. And so why is it? Oh, because we are using key, the same key, it combines them, so we don't want that. And let's say A, B, C, okay? And actually A, B, C, okay? So 5 comes first, that's right. That's the highest, 5 in a kind. Then when there's a tie, 4 comes before 3. That's what we want. That's right. So this works. Okay, so back to here. So we get a dictionary. Then we reverse sort, and we don't need to max. That's right. That's it. Okay, I think that's it. Try it. Yeah. Let's see. This should be correct. Oh, wait. Wait, this is not correct. No, this is actually wrong. So, wait, so you get a hand, then you get a dictionary, then you reverse sort the dictionary, sort by this function. Sort by reverse sort, then you want okay, now you want to turn a dictionary to a list of its values. Okay, so you want to turn a dictionary like that to just values. I believe that's normalize. Okay, so I believe that's it. No, that's not. Normalize, give the normalized vector. Okay, that's not. Standardize. No. there is, okay, so let's go to my Wolfram language tutorial. You can download for free. Just search for XR Wolfram language tutorial. You can go there, download for free. But right now we are looking for how do you get the values of a dictionary. So dictionary in Wolfram language is called association. Okay, association list, and then association list, association normal. Okay, not normalize, normal. That's right. So you want to apply this normal to here. Okay. So you get Q, no, that's still wrong. Yeah, you got worse. So if you say max, actually that works out. Yeah, so wait. Okay, very close. So here is a solution basically, just this function. But we need to trick this a bit. So this problem is mostly solved by the SortBy. Now the SortBy, you can have one single function that determines which element is greater than the other, or you can have a sequence of functions which are used in turn if there's a tie. So for us, now the problem is that right now we have this one single function that determines which comes first. But our function currently doesn't work for tie. So we need to resolve the tie. So we can either continue to modify this single function, or we can create a separate function. But I think a single function will work. However, we failed because that's why I'm doing all these. That's why I'm testing out these reverse sort and stuff. I think single function will work. So we have to think about this, okay? Think is the best way. So reverse sorts. Wait, why do you even need reverse sort? You don't even need reverse sort. You see? Yeah, you don't even need reverse sort. This max will do. But then there's a tie, okay? So that is why you need reverse sort. So let's see. We got so many confusing now. Yeah, so reverse sort gives you these. Then you reverse sort in normal. So I don't understand why is this. Why is this not working? This, I was thinking this should be one-shot solution. This should do it, but no. Okay, so let's think about sort by. You see, we can do this, and so we'll map this function to okay, so wait, why is it still? They shouldn't be. Okay, let's try more testing here. So a hand. Oh, this is wrong. Why the normal? Our normal is wrong. Why is it not work? Wait, normal works. Oh, you don't want the key. You gotta remove the key. That's why. So we need to remove the key. Okay. So let's go back to association list of get all keys. There it is. Keys. Okay. So let's back to the one-shot solution. Reverse sort, then just keys. Okay. No, we don't want keys. We want values. Okay. Values. So that's right. So let's look at this 311. That's right. That's what we want. Values at reverse sort. That's it. Okay. So here's our here's our solution. Okay. No, that's not right. Oh, God. What? Something is wrong here. Let's try this. That's what we want. Okay, so that's what we want. Oh, then there's a length issue. Okay, you see, so you got this versus this. There's a length issue. Then you just pad it, okay? You just pad the least. Yeah, okay. For example, pad least n and x, okay? Pad least by 0, by 5, 1, 2, 3, 4, 5 cards. Pad by 0. So that's what we want. Pad right, okay? So this is the function we want. So you just add pad right that by 0, okay? So this is one-shot solution. Yeah. No, it's still wrong. God. Oh, you forgot, wait, yeah, you forgot to add. That's right. No, it's still wrong. God, what is wrong? Oh, right. You need to pad it before you sort. That's right. So, that's right. So you need to pad it first. Okay, so you need to get the values first, then you pad it, then you apply the reverse sort. Okay, essentially it's one more time. No, shit. God. Okay, so what is going on? Oh wait, you cannot know. The order is wrong. Okay, so you get a dictionary first, then you need to reverse sort. Then you get you get a dictionary like that, then you reverse sort, so the biggest value comes to the front. or you can apply the value, get just the values, right? You just get the values, then you reverse sort them. Wait, you get the values, then you pad them, then you reverse sort. Why can't this work? That seems right. So you see, so this is essentially the criteria for the hand. You have 3 of a kind, then you have 2 of a kind. Yeah. Okay, so then you just sort by this order. So oh god, why is it? Let's test this, okay? Okay, let's write it out. Sort by let's see how it does. Sort by that. Did it sort it correctly? Yes. 4 to 1 is the best, 4 of a kind, then 2 of a kind, then 3 3, then 3 2. That's right. So this is the correct sorting. This is the correct sorting. So why is our code doesn't work? Reverse sort. Get the dictionary, then reverse sort the values of the dictionary. Then get the values. Then you pad. Okay, so okay, so you want to that, okay. This should be the answer, but why is it not correct? Oh, it is correct. 555, wait. 555, 3 of a kind. QQQ is 3 of a kind. Then JJTT is 2 pairs. Then KK is 1 pair. This is correct, but there's still missing something. Okay, once we do that, what if we have 2 full house? Okay, it's fantastic. Now we just utilize the sort by second function. So for example, here is one function. You see, now we just need a list of functions. So this is the first function. The second function is simply to sort them by alpha, by alphanumerical order of the string. So yeah, so the second function is just let's see. Alphabetic order. Okay, so we want a function now that given a string, well, given two strings, it alphabetic order. Okay, that's what we want. But alphabetic sort, that's the function we want. So the elements of list into alphabetical order. Okay. Alphabetic sort. Then you have lexicographic sort. What about alphabetic order? Close. We already solved the ranking problem. Right now, we have solved the ranking problem of the 7 types of hand. Right now, the problem is that if two hands have the same type, for example, both of them are 4 of a kind, how do you resolve that? Now, according to this problem, advent of code, you just sort them by, you rank them by the first character, then the second character. Okay, so which is easy to do. We already have these, several functions, alphabetic sort. But given our framework, the way we solved it, we need to put that into as a second function. Okay, yeah, the second function. Okay, let's just do this. Okay, so the second function is just that's right, first char. Okay, let's see if that works. I think that's oh, okay, so you need this needs to be a function. Okay, so 555 and QQQ, which one is better? Q should be better than T. Okay, so yeah, because our function here is, so you get, glad to see it working. Might help to do some tedious debugging. Is there a way to step through the execution? Usually you don't do that in Wolfram language, okay? Yeah, but you can. Jupiter says, I have a question. Why is pixel-based scroll in Emacs so laggy on Windows? I don't know. Don't use that. There's people saying they want pixel-based scroll. I never get exactly what's that for. Why do you need that? You scroll by character, that's fine. Why do you need the pixel-based, like there's several packages over the years trying to fix that? I never get why you need that. I don't recommend it because it makes Emacs much more complex to kind of do that kind of thing. Go with native, whatever the native system framework is the best. So Emacs, just by the way it is over the past 30-40 years, they don't natively support pixel scroll, so don't do it. You don't need it. When I don't get it. Why do you need the pixel scroll? Like why do you need the pixel scroll by pixels? I don't totally don't see the need. Okay, so yeah, I don't know about that answer to that. So anyway, we are almost solved the problem, but we seems to be stuck now. It's 90 minutes. We almost solved the problem, but now we actually the best way to solve the problem is actually just think instead of just like talking and trying and stuff. I just need to really just think about this. So we are using SortBy. Now in Wolfram language, SortBy allows you to have a list of functions. If the first function comes out a number that's a tie, then you use the second function, right? So right now we are using the second function. The first function simply gives us the type of hand, maybe a full house or 4 of a kind, 5 of a kind, that solves the problem. But in case there's a tie, let's say both of them are 4 of a kind, what you gonna do? I mean, let's say both of them are, full house, what you gonna do? I mean, 3 of a kind. So then we use the second function. Now, according to Advent of Code, when there's a tie, you should simply go by the alphabetical, the lexicographic order. You compare the first character, then the second character, okay? So we can do that. We use a list of functions, and our second function is simply return the sequence of characters, right? But however, here is a trick. So you want this needs to be a function, but you need the sense reversed here, because normally let's not use reverse sort here. Let's not use reverse sort. Then we have the same order. Wait. So if you don't use reverse sort, then you got it wrong again. What? 555 QQQ. Yeah, then you got it wrong. Why is that? Where's the pad? Oh, the pad is here. Yeah, I'm getting tired. The fuck. It's three of a kind. This is totally wrong again. Oh, you do need reverse sort here. That's silly. Because that's about the, yeah, you do need reverse sort. Oh, yeah, so then, right. Then you just, okay, got it. Yeah, so that's right. So do we have reverse sort by? Yeah, we do. Reverse sort by. How fantastic. So actually so it's not totally lexicographic sort, because you have the situation where A is greater than K, K is greater than Q, so they are not alphabetical at all. So right, so alphabetically A would be, first. Then Q would come after J, but it's not the case here. Q comes before J. So, oh yeah, so the order is so you need to write a function. Now the problem, okay, we know what's the problem. It's not alphabetical at all. We need to write a function, some kind of ordering representation that represents this specific order. A comes before K, K comes before Q, Q comes before J, J comes before T. Okay, and first of all, based on the first character, if there's a tie, then second character. Okay, so we need a function to represent this order. So okay, yeah, got another problem. Yeah, so our function works so far. The problem is this part. We need to fix this part. Okay, for example, let's delete that. Okay, if we don't do that, then we got this. So far it's pretty good. Three of a kind, two pairs, one pair, and random, right? We got a solution. But the problem is now there's a tie. You see this 555, three of a kind, and QQQ, three of a kind. So in this case, Q comes before T. That's correct. Okay. But what if we what if our problem has another pair such that for example, let's add let's add another pair. So QQQ, let's say KK, let's say KKK. Okay, then let's say another pair IJAAA. Okay, AAA. J4. Okay, so let's add this thing, so for example, if we have this input, then we list of hands, then we apply our list of hands. Okay, so we can see this is 3 of a kind AAA, 3 of a kind KKK, 3 of a kind QQQ. But according to the problem, which one comes first? A comes first, then K, and then Q. Okay, that works out. Okay, so let's just change the input a bit. So let's put Q here. Okay, so now copy. You see, now this is our sorted solution. But you see, the order is not correct when there's a tie. So A should be first, then K, then Q. Okay, so right now our problem is just create a second sorting function. Now, and the problem is to represent a function that represents the ranking of a sequence of 5 characters such that the first character is by this order. So how do you represent that? So let's say a single character. Forget about the sequence of characters. Let's just say a representation of order of one single character, and you want them to be ranked like that. So if it's a digit, then it's very easy. Okay, the larger digit wins. Okay, so but if it's not a digit, then so a single, so we can we can hard code it, but let's think about the interesting problem. How do you represent an order by this particular thing? I need to go to the bathroom. We are almost done, but advent of code always gets more complex. Almost 2 hours now, and I need to go to the bathroom. How many people watching? 5? 8. So far, am I doing good? Do I make sense? So you need find a function, let's say a single character that represents I don't want to continue. I need to go to the bathroom and walk. Let me take a break then. Let me just go to the bathroom. I'm back. Now I forgot my glasses. Okay. Okay, so back to the problem. So the problem right now is this. Okay, let's write it out, because when you write things out, you give you better thoughts. Okay. A function. The problem is to have a function that represents an ordering. Okay, ordering of this nature. Okay, so given two chars ordered by the above. Okay, so that is the problem. We need to have a function that kind of do this. So the function might be f, f char 1, char 2. Okay, so the problem is to have a function f char 1, char 2 that represent an ordering like this. So, for example, if the function is given a and let's try something interesting. JQ, okay, JQ, it should return, and there's an order. Okay, so how do you want to represent? I mean, if J is, it should so JQ, it should return less, something like that. So because J is less than Q, now how do you want to? It's a bit confusing because greater or less. So let's see, if this order Q is greater than J. Okay, so let's rename the function greater. Okay, so if so we name our function greater. So greater JQ returns false. Greater QJ return true. Okay, we want a function like that. Okay, and how do you do that? So this function takes two arguments. Each one is a single character. Okay, so let's see, 4 people. So how do you represent order? Okay, so we have sort function. We have sort by, reverse sort, and reverse sort by. Let's look at sort. Okay, sort takes the ordering function p. Okay, so takes an ordering function p. Okay, so we want, so this is our problem. But however, to use this function in our SortBy algorithm, in the way we worked on this problem, is that we need the function to okay, so actually we can have a hash table. Okay, so here is what we do. We simply have a hash table that returns A is, let's say, something like that. Okay, so 9 and 10, J becomes 11. That's right. Oh god, this is so simple now. 12, 13, A is just 14. Fantastic. So we want that. Okay, so we want a function that turns a char into a number. Okay, so something like that. And the 987, they return themselves. Okay, so yeah, we want a function that returns a character. So first of all, given a string, let me just type it out. So because when I type it out, I know we get clarity of thinking. So we got a sequence of characters. We want to turn it into a sequence of numbers by this hash algorithm. Okay, so let's encode this hash algorithm. Okay, now emacs power macro, keyboard macro, record macro, delete that, okay, and done. Okay, then we do that. Okay, there it is. Okay, so this is what we want. Okay, we want this. Okay, so this is gonna be a hash table, a dictionary. Okay, so and these are the wait. Okay, let me do this. Wait. Okay, so record hash, record the key macro again. Now, fantastic. Okay, we turn those characters into a number. This is our hash table. Sort table. Okay, sort table equals to, now this is association. So the way you do association, a hash table in Wolfram language is what did we do? Okay, sort table association. Okay, so this is how you do association in Wolfram language. Okay, so let's go back to here. Sort table, this is a association. Yeah, okay, so some of this is wrong because you got the arrow incorrect. Wolfram doesn't like that, so you need to have that Yeah. So this is our association, and let's see what happens if you sort them. Yeah, you sort them by number, by the value, correct. I mean the syntax is correct, okay? So now this is our association table, okay? Okay, let's remove that. It's association table. Let's move it here somewhere. This is our test stuff, okay? So, and now we don't need this. Okay, so let me just quickly code this so you can understand what I'm doing. So this function does this, okay? So now we have a function, so we need this function to be part of the SortBy. Now the SortBy, the second argument, is a list of functions. If the first function is a type, then you use the second function. So the second function will be, you get the hand. So this is a hand. Then it's a sequence of 5 characters. It's a string. Then you say string to list, okay? Split string. Okay, let's say okay, you want to turn a string into a characters. So what is that function? Let's see, characters gives a list of characters in string, so that's what you want. So not split string, okay? So you want that, for example, that turn a list of a string to a list of characters. Each one is a string of single character, okay? So that's a function. So you so that's right. So you basically just do it here, okay? Once you got that, a list of single characters, then you remap them into by this dictionary, okay, by this table. So for each character, how do you do it? Okay, so I don't know. So let's look up my Wolfram language association. You have an association, you have a character, you want to return the key. So let's see what you do. So let's see, sort table, and let's see, what does that work? It works, fantastic. Okay, let's say you have J, works. Now what if you have lowercase j? It doesn't work. Okay, so you make sure you have got a case match. Okay, so this is how you get a single character to their ordering value. Okay, so this is how you get a single character to their ordering value. Now we need to turn this, I mean this is a hard-coded case, so we need to turn this into applying this to the hand of sequence of characters. So what you do is okay, so you need to write a function. So let me show you. So this would be function, let's say char, okay? So that gives you a number that represents this character's ordering function, okay? So So you have this function. Now you want to apply it to a list of characters. Okay, this function you want to map it to a list of characters, which is this. Okay, this. Let me show you. Okay, so for example, let's try. So this part is just hand. For example, QQQ33. Okay. Did it work? No. What? Oh, wait, function, this is repeated. Wait. Yeah, so silly. Oh, okay, so wait, so let's say QQQ33, okay? That's right. That's right. That's right. So this is a function. So okay, so we got that function. We just need to put it here. Okay, the second function is going to be this. Okay, copy that. And that's it. That's our code. Let's evaluate the whole thing. That's our solution to this problem. I think, please, part expression x cannot be used as part specification. We got a oh yeah, so we got a, yeah, so you need a function here. So yes, that's right. So use something that's right. So we need this. Yeah, let's forget. It's getting very complex here, but I'm not sure you know what I'm doing, but I know what I'm doing. Okay. So, anyway, that should be the solution. Fantastic. It is correct. You see, AAA, 3 of a kind, then KKK, 3 of a kind, QQQ, 3 of a kind, but they got ordered correctly. A comes last because it's the heaviest, then AK, king, queen, then 555, then KK, 77, 2 pairs, then JJ and TT, JJ and TT 2 pairs, KK and 77 2 pairs, but which one is ordered first? I mean, IJK, K is greater than 10, so K comes first, correct. And the last one is nothing, random, you know, no pairs and nothing. So, but here we have to double check the KK versus KT. What is the original? KK versus the KT case. So KK versus KT. which one comes first. Well, so KK versus KT, KK is heavier, which is correct. Yeah, so we reorder these two. You see 28220. It becomes 220 and 28. That's correct. So this is correct. All we have to do now is we just multiply them. All we have to do is like this. Okay, let's see. What? Yeah, we don't want, okay, so let's remove the table form. Okay, so we want that map index at okay, we map a function to the list of ordered hand, and what function we want map it to. So we map a function to, yeah, so we map index. So okay, very easy. Okay, so let's do it here because I have completions. Map index, I mean, because emacs is more efficient to manipulate and stuff. So okay, so we want to map a function to that, and the function is gonna be 2 arguments, and the second argument is the index. Right, okay, so the second argument is the index. So, and what does it do exactly? You want to multiply the index by the bit number, okay, by the bit, the second part. Okay, so y is the index. Okay, so what you do is you index times index the first part of it, remove the least. Okay, so you get the index, which is the rank, times the bit. So the bit is you need to split string and get the second and turn it number to string. Okay, so string split, x by default is split by white space. Okay, then okay, so you can just say that at x, then you want to take the second part. Okay, let's do it this way. Okay, then take the second part, then that second part is the bit number, then you want to turn that to expression. Okay, so okay, that turns a string to a number, and that's it, I think. And you just sum. Okay, then you just sum. Okay, so let's try it. That's it. Then you just sum it. Now this sum is too high. Okay, total. Okay, now this is too high because we actually changed our input. So now let's revert the input to whatever is original problem. Oh God, QQQJA. So QQQJA. So you don't have this AAA. So that's right. So this is the input now. Okay, do that, do that, do that, and do that. Okay, let's try it again. Again, fresh. And what we got? Map indexed table form. What? Almost done. Wait, this is incorrect. So list of ordered hands. Okay, so you string split, then you take the second part, should be that, and to expression. Yeah, let's just try this. For example, this should return 28. Okay, that's correct. Now it returned the 28, then you take the index 1, multiply them. Nothing wrong with that. That should be. So why does it return that? Oh, because you don't want the table form. Yeah, stupid. Yeah, you don't want the table form. Let's evaluate. That's it. So you got these numbers 1, 2, 3, 4, 5. Now what you do? You add them together. Oh, correct. We got the solution. 6440. Okay, we got the solution. So now let's clean up the code. Okay, so let's just clean up the code. So here, this is the code. Okay, so we let's remove the shit, remove all the shit. Okay, so and just say total. Okay. Okay, this is our solution. Let's try one more time. In fact, you don't want table form here. Okay, let's try one more time. Perfect. Now, now let's get our own solution. I mean to play, please identify yourself. I wanna, God, I forgot to log into GitHub. Am I still logged into GitHub? Sign into GitHub. Okay, so I need to stop. Fuck, I forgot to log into GitHub. How many people are watching? 4. I need to complete this. Shall we? Yeah, let's complete it. Okay, so let me log into GitHub. This is tricky because I need to stop the stream. Okay, hold on a second. And I need my phone. I hope I can be back. Okay. Okay, I think I'm back. Am I back? Let's check. Is my streaming back? If you are here, concurrent views now 2 people. Can you see me? Yeah, I think I'm back. Okay, now we logged into GitHub. Now let's get our personal input. Okay, huge. Okay, so let's see. Okay, let's open that. Okay, let's save this input. Let's just say that. Okay, so this is our personal input, a file, 1000 lines. Okay, so now we just say read string, I believe. Yeah, read string input equals to that. Okay, this is our input, and read string. Let's see the documentation. What? Okay, not that. You need to put the cursor here. Let's see, read string file. Okay, so that's it. So that's it. That's a solution. Let's see if that works. This is a solution. We can make it much shorter, one single line. Okay, but let's try it. Okay. Fuck, we don't want. Okay, let's go back. Scroll down. This is our number 250957639. That's the end of a code. Submit. That's the right answer, of course. Okay, so now let's summarize. Since we did all this trouble to get this, let's just summarize. Okay. Summarize and clean the code. Okay, so we okay, so we don't need this big chunk of output. Okay, so that's our solution. Yeah, this is already what, 2 hours and 30 minutes. But here's a solution. So can you do it in one line? Yeah, sure. But okay, let me do it in one line. Okay. Okay, so let's do it in one line. Let's clean up. So map indexed. So hold on a second. I'm just very sloppily trying to get this done, but I'm not doing a good job. But okay, but here is a single line solution. Okay, here is the single line solution. Okay, yeah, it can be shortened much better, but anyway, so where is it? Starting here. Okay, there it is. And all these can be shortened. Let's see. There's so many ways to shorten it. Yeah, but let's not worry about it. But anyway, okay, here's the final solution, and we got it solved. Okay, that's advent of code. That's okay. So anyway, so this is advent of code day 7, part 1. We solved the problem, and that's it for today. Thank you guys for watching. Here is one single line solution, and of course this part can be moved somewhere here, so you actually get one single line here input. So let's see. Yeah, so just move this input to here. Okay, one single line solution, advent of code day 7, 2023. That's it for today. Kind of long, but it's interesting problem. And okay, so if you like my stuff, buy my stuff. Okay, pay me. Go to xardi.info, xarcode xardi.info, and go to the bottom. You can Patreon me, you can Amazon gift card me, you can PayPal me, you can buy my emacs tutorial, you can buy my emacs and emacs this tutorial and JavaScript in depth. Okay, and so that's it for today. Thank you guys for watching. Bye.